Hello everyone, in this video we are going to see the problem on the clipper circuit. So, this is the problem we have to solve now. So, here we have to design the clipper circuit. They did not give the clipper circuit, they have given input and output. So, input is nothing but the triangular wave and output is the mentioned signal. Here you can able to observe. This is the input signal, that is the triangular wave, and output is indicated with a green color line. Okay. So, first we have to observe the input wave and output wave. Then we can able to get the relation between input and output. That means that is actually called transfer characteristic equation. After identifying the relation, we have to write equation, and from that equation we have to design the circuit. That is the procedure we are going to follow. So, if you observe carefully here, this input wave, output wave are given with respect to time. So, on x axis time is there, on y axis we can take input voltage and output voltage, like that we have to observe. But you observe the relation between input and output only. That means, if input is changing from some voltage to some voltage, what is the output voltage? That is what we have to observe. So, here if you see carefully, the input is increasing from 0 to 5 volts, output is also changing from 0 to 5 volts only. That means, in this particular case, that means when input is changing from 0 to 5, output is also equal to input only. Okay. So, here I am writing. So, when input is changing from 0 to 5 volts, output is also changing from 0 to 5 volts. That means, simply we can write output is equal to input. So, but this is possible when input is changing from 0 to 5. So, this particular level is over. But after that, here also same nature is there. Okay, input is changing from 0 to 5 or input is changing from 5 to 0, both are same voltage levels. You have to see same voltage levels, whether it is increasing from 0 to 5 or decreasing from 5 to 0, same thing is there. And in that case also, when input is changing from 5 to 0 also, output is also changing from 5 to 0. So, this portion is output is equal to input, this portion also output is equal to input. Those two things I have covered in this range only. Okay. After that, input is changing from, that means triangle signal you observe, input is changing from 5 to 10 here, 5 to 10, but output is not changing from 5 to 10, output is changing from 5 to 8 only, 5 to 8 only, that is what I am writing here. So, input is changing from 5 to 10, but output is changing from 5 to 8. So, here we have to give one mathematical equation. Okay, in the previous case, that means when input is changing from 0 to 5, output is also same thing. That is why we have given output is equal to input. That means here y is equal to mx, where m is equal to 1, straight line passing through the origin in the transfer characteristic equation. But here what is happening in the second part? That means when input is changes from 5 to 10, output changes from 5 to 8. And here also same thing, reverse process, input changes from 10 to 5, output changes from 8 to 5. So, both characteristics are same, this side and that side. Okay. So, now what we need to do, how to give the mathematical expression for this particular thing. So, to have this particular mathematical equation, so that is a straight line only, because in the transfer characteristics, if you observe, input we are taking on the x axis, output we are taking on the y axis. So, when input changes from 0 to 5, we have observed that output also changes from 0 to 5. So, how the graph will come? V naught is equal to Vi means a straight line passing through the origin, but after that only changes are happening. When input changes from 5 to 8, output changes from 5 to 10, input changes from 5 to 10, output changes from 5 to 8. So, it is 10 actually. So, it should not reach 10 value, it should reach only 8. So, like this the slope will be changed. The slope will be changed. So, from here to here the change in input is 5 volts, but from here to here the change in output is 3 volts only. So, 8 minus 5 is 3, here 10 minus 5 is 5. So, this is called change in y variable, this is called change in x variable. So, slope m is equal to, you will get 3 by 5. Okay, change in output by change in input. So, your input is changes from 5 to 10, but output changes from 5 to 8. So, there is a change in 3 volts in the output when you have the change in 5 volts in the input. Okay, this is possible after input voltage is beyond 5 volts only. That is what you have to observe. So, this is actually change in output by change in input. This is what we have observed from the waveform. till here we did not start designing the clipper operation. Okay. Now orally once again I am repeating this one. When input below 5 volts, I am talking for the positive half cycle only, that is also you have to remember. When input is below 5 volts, that means from 0 to 5. Okay, we did not take the negative voltage. Okay, first we will design the clipper circuit for the first positive half cycle only. So when input is below 5 volts, output is equal to input. When input is above 5 volts, clipping operation has been done. Okay, there is a output decrement is there in the input. Okay, when input changes from 5 to 10, that is what we have to observe. So clipping needs, okay, clipping needs above 5 volts, no clipping below 5 volts. So this is what our observation. This one can be told just by seeing the output and input waveforms. Okay, so above 5 volts, that means if you take 5 volts is the reference voltage, above the reference voltage you need clipping operation. For example, I need to design the circuit using shunt clipper. Okay, using shunt clipper I need to design. So I will take the circuit like this basically. So I need above clipping operation, above the reference voltage level. That means from the basics we know P side should be above. If the P side of the diode is above, then we are going to clip the input signal above the reference voltage level. Okay. So what is that reference voltage level? 5 volts. That is also we have understood, because after 5 volts only there is a decrement in the input. But if you take the circuit like this, what is happening? You will get the input and output waveforms like this. The output is given after 5 volts, exactly you will get 5 volts, but below 5 volts there is no change. Okay, below 5 volts there is no change, but above 5 volts you will get exactly output is equal to 5 volts only. But here we do not want this one. Okay, when input is in between 5 to 10, output should change from 5 to 8. So there is a change in the slope. The slope is not equal to 0. So we have to do some modification in this particular circuit. So what is that modification means? Up to here it is okay, clipping above, so P side is upside, and clipping is to be done after 5 volts. So battery also 5 volts only, but slope is to be changed. For that we are inserting one more resistor here, and you say this is R1 resistor, this is R2 resistor. Here input voltage we are applying, this is the output voltage. We are working for the positive half cycle only. Okay, and it is the ground. So you understand one thing here, when input is less than 5 volts, diode will go to reverse bias, that means open circuited, that means output is equal to input we will get. From our basic operations simply we can tell that one. But whenever input is greater than 5 volts, diode is getting the forward bias. Diode is getting the forward bias. At that particular case, output is given by, according to voltage division rule, V0 is equal to Vi into R2 by R1 plus R2. This is the voltage drop we will get across the output. Okay, this is the voltage drop across the R2 actually, and we can take here plus 5 volts also, because in the output case we have plus 5 volts. Okay, so anyhow from this one V0 by Vi is equal to slope. What do we get here? R2 by R1 plus R2. But from the waveforms already we got this particular slope. In the transfer characteristics, when you have V0 by Vi, that is the called slope, and that is given by 3 by 5. Already we have seen this one. That means R2 must be equal to, we can design, we can take the value of R2 is equal to 3 kilo ohm for example, and to satisfy this ratio R2 by R1 plus R2 is equal to 3 by 5, R1 must be equal to 2 kilo ohms. Okay, R1 is 2, R2 is 3, then we can able to satisfy this particular thing. So we can able to take, this is called design. Okay, when you obtain the element values in the circuit, that is called design. So R1 is 2 kilo ohm and R2 is 3 kilo ohm, like this we will get. Okay, so we have designed the circuit for the upper half cycle. Okay, for the positive half cycle of the triangular signal, we have designed the circuit. Now if you have input is greater than 5 volts, you are going to get output is like this. Okay, output changes from 5 to 8 only. Okay, if you have doubt, okay, you take the output waveform here, output equation here, output is equal to, and output is actually involving diode, because that is under forward bias after 5 volts. Forward bias means short circuit, 0 volts we will get from the diode and 5 volts is from the battery, and we have voltage across the 3K. Okay, voltage across 3K means 3 kilo ohm resistor is to be multiplied with current flowing through the 3K. Current flowing is given by Vi minus 5 by 5K. So, like this we have to write. So, it is equal to Kk will be cancelled. So, what we will get here 3 Vi by 5, 3 Va by 5, and we have here 3, okay, I will write here one more step, 5 minus 3, like this we will get. That means 3 Va by 5 plus 2, like this we will get. So, now this is the equation we have to follow, that means V naught is equal to 3 Va by 5 plus 2. This is the equation we have to follow. This is the equation we have to follow when input is greater than 5 volts. Okay, when input is greater than 5 volts, this is the equation we have to follow. You can able to check with the voltage levels now. So, after 5 volts, that means exactly 5 volts, what is happening you see. When input is 5 volts, what is happening? You substitute here input is equal to 5 volts, 5 by 5 will be cancelled, 3 plus 2 is 5. So, when input is 5, output is 5, this is the point. Now, you take input is 10, output you should get 8, input is 10, if you substitute 5 ones are 5 twos are. So, 2 into 3 is 6, 6 plus 2 is 8, you are getting this one, this output voltage you are getting. Okay, when input is 10, we are satisfying output is 8, when input is 5, output is 5, we are satisfying those two. So, this equation is valid now. Okay, so this circuit is correct. Okay, using this particular circuit, we are going to get when input from 0 to 5, output is 0 to 5, when input is 5 to 10, output is from 5 to 8, that is over. But it is for positive half cycle only. When the negative half cycle is also required, okay, then what we have to do? Then what we have to do? So, here clipping is also there below minus 5 volts. Okay, this is minus 5 volts. So, below minus 5 volts clipping is there. So, we have to extend this particular circuit now. So, simply what I will do in the sense, now this portion design is over. For that we have got the circuit like this. Above 5 volts, one more resistor we have taken. So, this is Vi, R1, R2, this is 5 volts, and R1 and R2 we got 2K and 3K. So, this is 2 kilo ohm and this is 3 kilo ohm. So, using this one, what is the output you are getting? Once again just I am writing, this is the input wave, if you take that one only, but using this particular process we will get the clipping operation for the portion of the input signal which is beyond 5 volts only, 0, minus 5, minus 10. So, you will get below 5 volts output is equal to input, but above 5 volts you will get output is like this. This voltage is 5 volts, 8 volts. Okay. Now, we need clipping in this portion also. So, below minus 5 volts. When you have clipping below certain amount of reference voltage level, how to take the diode? Diode we have to take like this. Already existing circuit I am drawing again, 5 volts and resistor 2K and this is 3K. So, clipping below, so N side is upside and clipping below minus 5 volts. So, reference voltage is minus 5 volts. So, we have to reverse the terminals of the battery, and if you observe one thing, the slopes, okay, in the negative half cycle also same slopes are there compared to the positive half cycle. So, again same resistors 3K. So, you can able to check according to this particular circuit, exactly you are going to get the clipping operation in both sides. In both sides you will get the clipping operation. So, for the triangular wave input we will get exactly what is required for the output waveform, that is what we are going to get with this particular clipper operation. Okay. So, we have completed the design of the clipper circuit. Thank you.